हेलो माय डियर मैकेनिकल इंजीनियर्स, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? अपन केमेन आछेन यलवनारू की हालचाल? Myself Chandrasekhar welcoming you all to this wonderful series which is called Old is Gold. Why this series is known as Old is Gold? Because we are discussing the important GATE PYQs from early 90s. You must be having the solution or the sessions for the previous last 5 years or 10 years GATE papers, but you may not be having the questions which had been asked in 90s and which are still relevant for your preparation. So that is the reason this series is planned for the GATE aspirants, so that it will help you to improve your fundamentals, improve your preparation, and you will be ahead of your competitors. So please guys, do join me fast, and those who are already here, please respond me through the comment section if my audio and visual quality are fine. Can you guys properly hear me? So today I will be discussing some important question from early 90s from the subject of heat transfer. Shall we start without any further delay, without any wastage of your time? Let us start. But before that, let me quickly introduce myself. I am mechanical engineering graduate from IIT Delhi. Most of the students already know me, and I have also cleared engineering services examination. I had worked in Steel Authority of India Limited, as well as I have worked in a private consulting firm. From last 11 years, I have been into teaching, guiding the students who are preparing for various competitive examination. मेरी आवाज आ रही है क्या? क्या आप सुन पा रहे हैं मुझे? देख पा रहे हैं? Please do write me in the comment section those who are here. Hi Rajput, welcome, good evening, what's up? So guys, keep your pen, notebook and calculator and try to solve as many questions as possible on your own, so that you develop the right confidence, you develop the understanding, you develop the thought process. And I am quite comfortable in these many subjects of mechanical engineering. So if you want to connect with me, there is a mail ID, my official mail ID, and you can join me on the Telegram also, which is Mechanical by Chandrasekhar. The link is also there, as well as there is a QR code also. You can scan that. All right. So keep your pen, notebook and calculator, sit back, relax and enjoy this beautiful session, and try to involve yourself as much as possible, because the more the students involve, the better energy we get, and we try to bring the concepts, or we try to bring the sessions in more fruitful, more energetic, more simple and beautiful manner. Hi Ritika, welcome, good evening. Once again, I welcome you all from the bottom of my heart to this wonderful session. Your participation will be highly appreciated. Your energy level, your enthusiasm, your positivity will be highly appreciated in this session. All right. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalamu Alaikum, Wanakam. So those who are preparing for GATE 2025, if you know someone, if you know your juniors who are preparing for GATE 2025, there is an important workshop is going to be started at 7:30 p.m. on our BYJU'S exam prep app. You just have to register yourself, and the session, the workshop will be all about the strategy to clear the GATE 2025 examination in the first attempt. मेरी आवाज आ रही है क्या? Knock knock. Please mark your presence by writing in the comment section. Am I properly audible and visible to all of you? So there is question number 1 on your screen. The question is from the critical insulation. There are two insulating materials of thermal conductivity K and 2K, which are available for lagging a pipe. What is lagging? Lagging is called as heavy insulation. And lagging reduces the heat transfer rate. So these two materials are available for lagging a pipe which is carrying a hot fluid. If the radial thickness of each material is same, what will be the answer? This question was asked in GATE 1994. So Option A says material with higher thermal conductivity should be used for inner layer and one with lower thermal conductivity for the outer layer. Material with lower thermal conductivity should be used for inner layer and one with higher thermal conductivity for outer layer. It is unimportant whatever with the sequence of the insulating material used. And option D says it is impossible to judge unless the numerical values of dimensions are given. Yes, tell me which of the following options is correct. There are two parameters. One is lagging. Lagging is called as heavy insulation. It reduces heat loss. Lagging reduces heat loss or heat transfer rate. To decrease the rate of heat transfer, to reduce the heat transfer rate, the material with the lower thermal conductivity should be inner layer, and then 2K, then 3K, and like this 4K. This should be the insulation. This should be the order of the insulation. But if we want to increase the heat transfer rate, how the insulation should be done? The material with the higher thermal conductivity should be the first material, then 3K, high money K, then 2K, then K, like this. So if our objective is to increase the rate of heat transfer, then 4K material should be inner layer, 3K outer layer, 2K is the outer layer, and so on. But because the question is all about the lagging, this is where people commit mistake. They do not understand. Lagging means heavy insulation which reduces the heat loss. So the objective of the lagging is to reduce the rate of heat transfer. And if you want to reduce the rate of heat transfer, the first material should be highly insulating material. The first material should be highly insulating, means should be having least value of thermal conductivity. B is the answer, Kumar. यही तो गलती करते हैं. Lagging means heavy insulation. ऐसा समझिए इसको, the first material is the highly effective material. If we want to insulate a system, the first insulating material will be the highly effective, then the second will be lesser effective, the third will be lesser effective. So if we want more effect to be developed, then if the objective is to increase the rate of heat transfer, then the material with the highest thermal conductivity will be the first material to be insulated. But if the objective is to reduce the rate of heat transfer, then the material which is highly conducting should be the highly insulating should be the first material. Are you getting it? Is this clear? Yes or no? Please write yes or no in the comment section. If you have understood it, please write Y, and if you don't understand it, please write N. So B will be the correct answer because of the word lagging mentioned here. That is because of the word lagging which is mentioned over here. I hope it is clear, right? Can we proceed further? Now the next question. For a given heat flow and for the same thickness, the temperature drop across the material will be. क्वेश्चन ऐसा नहीं है, थोड़ा सा इसमें कुछ मिसिंग है. लेट मी सी व्हाट एग्जैक्टली इज मिसिंग. द टेम्परेचर ड्रॉप इज हाईएस्ट, ऐसा कुछ है. द टेम्परेचर अक्रॉस द मटेरियल विल बी मैक्सिमम 4. ये क्वेश्चन. द टेम्परेचर ड्रॉप विल बी मैक्सिमम 4. यस, व्हाट विल बी द आंसर? सो कैन वी से according to Fourier law? Fourier law is used for conduction. So Q is equal to Ka delta T by L for the given heat flow, that is constant. Same thickness, L is constant. Area is not mentioned, so it will be taken as constant. So delta T is inversely proportional to K. So more will be the thermal conductivity. As K increases, delta T will decrease. So thermal conductivity for copper is maximum, it is a pure metal. Then steel, that is alloy of the metal. Then glass wool. And then refractory brick, it is highly insulating brick. Refractory brick is highly insulating. So if we want a temperature drop to be maximum, so the material, it will be refractory brick. Refractory brick is highly insulating. It is insulator. It is thermal insulator. It is used for insulating the furnaces. Refractory brick is used for insulating the furnace walls. So D will be better. People have a doubt in C and D. Glass will be having more thermal conductivity. Refractory brick will be having the least value of thermal conductivity. That is why option D will be the answer. I hope it is clear, right? Yes. Ritika, Rajput, Maniket, D will be the answer. The next question is again from the critical insulation. What will be the answer for the next one? Next question, give me the answer for this one. For a current carrying wire of 20 mm diameter, current carrying wire means a cylinder. It is a cylinder of 20 mm diameter exposed to air, convective heat transfer coefficient of air. Maximum heat dissipation occurs when the thickness of insulation is. Insulating material is having a thermal conductivity. So critical radius of insulation is K for the insulating material upon H0. That is the critical radius of insulation. What is the thermal conductivity of insulating material? 0.5. What is H0? That is 20. What is 0.5 by 20? Or that is meter. So it will be 500 by 20 millimeter. That is RCR. R's critical radius of insulation is 25 mm. Now, where the people commit mistake, it is the thickness of insulation which is asked. It is not radius of insulation which is asked. So, critical thickness of insulation is RCR minus R0. Critical thickness of insulation. So, 25 minus diameter is 20 mm. D0 is equal to 20 mm. R0 will be equal to 10 mm. Do not commit these type of mistakes. 10 mm. That will be critical thickness of insulation. 15 mm will be the answer. D will be the answer. Yes, well done. Maniket, kya hua? Yes, Rajput. D will be the answer. Kumar, it is not B, it is D. Critical radius नहीं पूछा, critical thickness पूछ रहा है question में. It is about the critical thickness, not the critical radius, which was asked in gate 93. I hope it is clear. So do not misunderstand the question and do not commit the silly mistakes. The next one, asked in gate 1998. The temperature variation under steady state heat conduction across a composite slab of two material. There is a composite slab which are having a series combination, isn't it? These slabs are connected in series like this, and the heat flow is taking place like this. Q will remain constant because it is series combination with thermal conductivities of K1 and K2. First material is having thermal conductivity K1 and the second material is having thermal conductivity K2. Then which of the following statements holds true? K1 cannot be equal to K2. K1 cannot be equal to K2. K1 cannot be 0. Now, we can say Q is equal to minus Ka into dt by dx is constant. Because Q is constant because of series combination. Area is constant. Area is also constant. There is no heat generation. There is no heat stored in the system. That is why Q, the rate of heat transfer, will be constant. So we can say K will be inversely proportional to dt by dx. dt by dx is the slope. So more will be the slope, less will be K. So we can say here the slope is less. For material 1, do you agree slope is less? The more horizontal means less slope. So dt by dx for 1 will be less than dt by dx for 2. Isn't it? So which means K1 will be greater than K2. Which means K1 will be greater than K2. Option A, yes, everybody had given me the correct answer. Hi Shiva, Maniket, Rajput, Kumar, well done guys, well done, keep it up. Everyone, please do participate. Again, the question is from the insulation. Earlier, lot of questions used to be asked from the critical insulation. Now, what will be the answer to this one? Answer to this one, this was asked in GATE 1999. It is proposed to coat a 1 mm diameter wire. This is 1 mm, R0 is 0.5 mm. R0 will be 0.5 mm with enamel paint. The thermal conductivity of the paint is 0.1 to increase the heat transfer with air. If the air side heat transfer coefficient is 1000, that is H, the optimum thickness of enamel paint should be. Find out RCR first. K insulation by H0. What is K insulation? That is 0.1 into 10 to the power 3 if we want to be to convert it into millimeter upon H, that is 100 millimeter. So it is 100 by 100, that is 1 mm kya? It is 1 mm. RCR will be equal to 1 mm and critical thickness is RCR minus R0. So 1 minus 0.5 mm. B is the answer. B होगा ना यार, C कैसे होगा? Is it C? फिर वही गलती कर रहे हैं क्या आप शिवा मॉन्डल? C होगा क्या? सीरियसली देखने दो मुझे, मैं तो गलती नहीं कर रहा कहीं. B तो होगा. Why you guys are saying C? Thickness, thickness, thickness. Thickness is critical thickness or optimum thickness is RCR minus R0. यही गलती नहीं करना है, एग्जाम में भी नहीं करना है, इसलिए बार बार ऐसे क्वेश्चंस पूछे जाते हैं. Sometimes the question is asked from the thickness of insulation, sometimes it is asked from the radius of insulation. All right, correct? Yes, TPM, well done. Shiva, good, good. Mandal, keep it up guys. Do participate, do solve the questions before I give you the answer on the board. This is what was asked in 1992. मुझे ये बताइए पहले ये क्वेश्चन किस टॉपिक से है. There are two rods, one of length L and the other of length 2L are made up of the same material. Both are made up of same material, which means thermal conductivity is constant for both the materials and have the same diameter. The diameter is also same. Same material, same diameter. The two ends of the longer rod are maintained at 100 degrees Celsius. One end of the shorter rod is maintained at 100 degrees Celsius while the other end is insulated. The shorter rod, one end is insulated and other is maintained at 100 degrees Celsius. Both the rods are exposed to the same environment at 40 degrees Celsius. H is also constant. किस chapter का question है? The question is from the fin theory. Well done. Yes. The temperature at the insulated end of the shorter rod is measured to be 55 degrees Celsius. What is the temperature at the midpoint of the longer rod? बताइए. What should be the answer? Which formula you are supposed to apply? Which formula we are supposed to apply here? What will be the answer to this one? Can you give me the answer? Everybody, please give it a try. Whenever is a rod or a bar or a fin is exposed to the environment, one end of the rod or the bar is at a source, temperature source or heat source, and the other end is and the periphery is exposed to the environment, it is a case of fin theory. What should be the answer? Look, if there is a rod which is connected to heat source at both the ends, this is TS, this is TS, the length is, let us say, 2L. The length is, let us say, 2L. If we draw the temperature profile, then the temperature profile will be like this. This is TS, this is also same temperature TS, and the temperature is minimum here. This is how the temperature profile, and Q will be 0 here at the center. So this longer rod can be replaced by two rods because here Q is equal to 0. At this point Q is equal to 0, it means we can assume it to be insulated. So it can be treated as two shorter rods of length L. One end is maintained at Ts temperature and another end is insulated. And there is another rod of the same length L and one end is exposed to this and another end is insulated. So the temperature profile will be same for these. Now the question says, question क्या कह रहा है? The temperature at the insulated tip is 55 degrees Celsius. Don't you think that this temperature is 55 degrees Celsius? If the temperature at the insulated tip for the shorter rod is 55, then at the midpoint of the longer rod the temperature will be 55 degrees Celsius only. नहीं होगा क्या? Do you guys understand it or not? So it is not about any calculation as such. The question is not about any type of calculation as such, but if you understand the basic concept that the longer rod can be treated as the two small rods which are joined together at the insulated tip. So the temperature profile will be same for both the situations. I hope it is clear. Yes or no? Please do let me know if it is clear or not. Is this all clear to everyone? Yes, can we proceed further? समझ में आया आपको? 55 डिग्री सेल्सियस will be the answer. The next question, ये 5 marks का पूछा गया था. Let us try to solve this one. So some of the subjective questions are also important to improve your understanding. So this is the subjective type of question. Earlier there used to be some questions in GATE which used to be asked for, which had been asked for 5 marks. तो ये उनमें से ही एक क्वेश्चन है. There is an iron rod. Rod means it is again the fin theory. There is an iron rod. Rod means a cylindrical. Thermal conductivity is diameter is 15 mm and 160 mm length. It is finite length fin. It is finite fin. Extends out of a hot surface of temperature 150 degrees Celsius, that is Ts, into the environment, that is T infinity. The free end END. The free end of the rod is insulated. It is an example of short fin with insulated tip. Second case, this is an example of short fin with insulated tip. If the film heat transfer coefficient, that is H, is given as 25 watt per meter square Kelvin, calculate the rate of heat flowing out of the hot surface through the rod and the temperature at the insulated end of the rod. So we need to find out two things, Q fin and temperature at the tip, or minimum temperature. Temperature at the tip, insulated tip. These are the two things which need to be calculated. So Q fin is equal to K into cross sectional area A into M into theta s 10 hyperbolic ml. This will be the formula for Q fin. And T at tip minus T infinity upon Ts minus T infinity is equal to 1 upon cos hyperbolic ml. This will give you T tip. These are the two formula to be used. First of all, find out the value of M. First of all, find out the value of M. Can you find out the value of M? M is equal to under root of HP by K into cross sectional area. P is the perimeter. Or for a circular cross section fin, it will be 4H by K into diameter. What is the value of M? That is fin coefficient, that is meter inverse is the unit. Under root of 4 into H, put all the parameter in their SI unit. Thermal conductivity is 41.5 into D, diameter 15 mm, 0.015 meter inverse. What is the value of M? Do find the value of M. M की value बताइए. Everyone, please do let me know the value of M. in meter inverse. That is called as spin constant. It is known as spin constant. First of all, find out the value of 100 divided by 41.5 divided by 0.015 under root answer. It will be 12.67 something. 12.67 क्या आ रहा है बताइए. What is the value of m? So m will come out to be 12.67 meter inverse. Are you getting this or not? Are you getting m to be 12.67 meter inverse or not? Then Q fin is equal to K. What is the thermal conductivity of the fin? Thermal conductivity is 41.5 into area pi by 4 into 0.015 square KAM 12.67 into theta s, that is Ts minus T infinity. Ts minus T infinity is 150 minus 36 into 10 hyperbolic 12.67 into L. What is L? L is 160 mm, that is 0.16. 0.16. What will be the final answer for Q fin? Can you do the calculation? Can you guys do the calculation and let me know the answer for Q fin into 0.16, then 10 hyperbolic into 150 minus 36 into 12.67 into pi 0.015 square into 41.5 divided by 4. Are you getting 10.23 watt? Are you guys getting final answer? It is something around 10.23 watt. आ रहा है क्या? That is Q fin. And T at the tip minus T infinity upon Ts 150 minus 36 is equal to 1 upon cos hyperbolic m is 12.67 into L is 0.16. So from here we can find out T tip. What is the value of T tip? Can you solve for T tip? See, 12.67 into 0.16, then cos hyperbolic ml. (150 minus 36 divided by this answer) plus 36. Are you getting 65.516? It is 65.516. It is hyperbolic function. हाँ 40 क्यों आ रहा है? Are you getting 40? चेक करिए और बताइए मुझे ये मैच कर रहा है या फिर 40 मैच कर रहा है. एवरीबडी प्लीज डू लेट मी नो. शिवा, मनिकेत, फिर से चेक करिए अपनी कैलकुलेशन को. डू ट्राई योर कैलकुलेशन अगेन. 10 हाइपरबॉलिक थोड़ी होता है, यहां थोड़ी होता है. 10 हाइपरबॉलिक तो क्यू फिन में ही तो होता है. क्यू फिन में होता है, एफिशिएंसी में होता है. एफिशिएंसी ऑफ द फिन 1 upon ml into 10 hyperbolic ml. Effectiveness of the fin, that is km by h into 10 hyperbolic ml. ये जो टेम्परेचर प्रोफाइल है ये तो हाइपरबॉलिक फंक्शन, यहां तो कॉस होता है. हियर इट इज कॉस हाइपरबॉलिक. यस आशीष, फॉर्मूले याद नहीं है आपको. शिवा, फॉर्मूले भूल चुके हैं आप? डू रिवाइज दिस फॉर्मूला. 65.6, 65.5 will be the answer. Right? Let us move to the next one. Next is from the convection. The next question, इसको solve करके बताइए. A fluid flowing over a flat plate. This was asked in GATE 1992. A fluid which is flowing over a flat plate has the following properties. Dynamic viscosity is given by 25 into 10 to the power minus 6. Specific heat in kilojoule it is given. Thermal conductivity. The hydrodynamic boundary layer thickness is measured to be 0.5 mm. The thickness of the thermal boundary layer. So the hydrodynamic or velocity boundary layer and the thermal boundary layer thickness are connected by Prandtl number. So we need to calculate the Prandtl number. Hi Uma, welcome. I am all good. How are you? So what is Prandtl number? Prandtl number is kinematic viscosity upon thermal diffusivity. What is kinematic viscosity? Dynamic viscosity per unit density upon alpha is K by rho into Cp. So if you simplify this, so the Prandtl number expression is mu into Cp by thermal conductivity of the fluid. This is the property. Prandtl number is the property of the fluid. Calculate the value of Prandtl number using all the parameters in their SI unit. Dynamic viscosity is 25 into 10 to the power minus 6. Cp is 2000 joule per kg Kelvin. Thermal conductivity is 0.05. What is the value of Prandtl number? What is the value of Prandtl number you will be getting? Everyone, please solve for Prandtl number. What is the Prandtl number? So when the Prandtl number for laminar boundary layer, it is for laminar boundary layer. When the Prandtl number is less than 1, then delta V is less than delta T. Velocity boundary layer thickness is, Prandtl number is equal to 1, then delta V is equal to delta T. Prandtl number is greater than 1, then delta V will be greater than delta T. This is how Prandtl number is related. Prandtl number 1 आएगा, 1 नहीं आ रहा क्या? It should be 1. 1 आ रहा है कि 10,000 आ रहा है? Maniket, is it 1 or 10,000? 25 into 2000. Put all the parameter in their SI unit. 2 kilojoule को joule per kg Kelvin में put करना होगा. यही तो mistake करते हैं students. Put all the given parameter in their SI unit only. So that is 1. Because the Prandtl number is equal to 1, then delta V is equal to delta T. If the hydrodynamic boundary layer thickness is 0.5 mm, then the thermal boundary layer thickness will also be 0.5 mm. Yes. The answer B is correct. B will be the right answer. Getting it? So it does not matter. It does not matter whether the boundary layer is laminar or turbulent, because when the turbulent boundary layer, in case of turbulent boundary layer, when the boundary layer is turbulent, delta V is always equal to delta T. It is not a function of Prandtl number. For turbulent boundary layer, delta V is always equal to delta T, irrespective of the Prandtl number. But if it is laminar boundary layer, then Prandtl number decides. But because Prandtl number is coming out to be 1 only, it means delta V is equal to delta T. Whether it is a laminar boundary layer or it is a turbulent boundary layer, it does not matter. I hope this is clear. The next one, can you match the following? What is Grashof number? Grashof number is the ratio of buoyant force to viscous force, isn't it? Reynolds number is the ratio of inertia force to viscous force. Inertia force is replaced by buoyant force. This is used in forced convection. And Grashof number is used in free or natural convection. So Grasov number is in free convection 3, A3. A3. Simid number. What is Simid number? Look, there are three properties: kinematic viscosity, thermal diffusivity, and mass diffusivity. This is momentum diffusivity. This is thermal diffusivity. And this is mass diffusivity. All are having the same unit, meter square per second. So Prandtl number is equal to kinematic viscosity by alpha. Lewis number is equal to alpha by d. This is Prandtl number. This is Lewis number. Is the ratio of alpha by d, and there is Simid number, that is equal to kinematic viscosity by d. Mass diffusivity, that is called as Simid number. So it is used in mass transfer. Lewis number and Simid number are used in mass transfer. So for B, Simid number is for mass diffusion. B1. Weber number is coming from the fluid mechanics. Weber number is related with surface tension. What is Weber number? Weber number is the ratio of inertia force by surface tension force under root. So here it is the surface tension. So C5. And Fourier number is used in transient heat conduction. What is Fourier number? The ratio of thermal conductivity to heat transfer. Thermal conductivity, or the ratio of conduction to the heat storage capacity, that is used in transient heat conduction. 3152. Yes, Rajput, well done. 3152. Yes, Shiva, good. 3152. Let us move further, but before that, there is a mega mock test which is open till tomorrow. The third mega mock test. अच्छा, buffering हो रहा है क्या? Is it buffering? Are you facing? So tomorrow will be the last day for this third mega mock test, subject-wise test. If you have not attempted this test, please do attempt it. It will help you to improve your understanding. It will help you to boost up your confidence level. The registration is completely free. You just register yourself, and the test will be on BYJU'S app. If you have not installed the BYJU'S app, please do install it through the link which is there in the description box. There is a bit.ly link in the description box. You can install, you can download the BYJU'S exam prep app. Alright, so this is the entire schedule. We are at test number 3 here. The result will be announced on 18th of November. The syllabus of this test is production engineering, industrial engineering, material science, and IC engine. And the pattern of the examination will be same as that of your actual gate pattern. Then there will be 4th test, and then there will be full length test. So please do attempt these tests, and based on your performance, you can unlock our test series also for the discounted prices. Next, let us move to the questions from the radiation. This was asked in 88. The next question from the radiation. For a glass plate, transmissivity, tau, and reflectivity, rho, are specified as 0.86 and 0.08. The absorptivity for any surface, can we say, according to energy conservation, alpha plus rho plus tau is always equal to 1. So we can find out absorptivity alpha. Alpha is equal to 1 minus rho plus tau. What will be the answer? I think it is option D. एक ही option बचा है. 0.86 होगा नहीं, 0.08 होगा नहीं, 0.86 plus 0.08. So 1 minus answer 0.06. D will be the answer. D will be the correct answer. What is a diffuse radiation surface? When do we call the surface to be diffuse? radiation in all the direction, that is called as diffuse. The opposite of specular surface, if the radiation is taking place in all the direction, it is called as diffuse surface. So radiation intensity independent of angle. Radiation intensity independent of angle. It is same in all the direction. Radiation in all the direction is same. That is called as diffuse radiation. Option A. A will be the answer. Yes, Shiva Rajput. A will be the correct answer. And there is another surface which is called as gray surface. Gray surface, the radiation independent of wavelength. Radiation independent of wavelength. That is called as gray surface. So the surfaces are what we analyze in our radiation. We assume the surface to be diffuse and gray. So if the radiation intensity is independent of both the angle and wavelength, that is called as diffuse and gray surface. That is called as diffuse and gray and diffuse. D will be for gray plus diffuse surface. Emissive power independent of wavelength, that is called as gray. So A will be the answer, right? The next one, this was asked in gate 94. The shape factors with themselves of two infinitely long black body concentric cylinders. This is 1, this is 2. The surface 1 is insulated from inside and surface 2 is insulated from outside. राजपूत, ये जो डिफ्यूज और ग्रे डिफाइन करते हैं, दे आर हाइपोथेटिकल एंड दे आर डिफाइंड फॉर ए पर्टिकुलर वेवलेंथ रेंज. हम जो बात कर रहे हैं, हम बात कर रहे हैं थर्मल रेडिएशन की. सो फॉर थर्मल रेडिएशन द बॉडी इज अज्यूम टू बी ग्रे एंड डिफ्यूज बेस्ड ऑन द वेवलेंथ रेंज 0.1 माइक्रोमीटर टू 100 माइक्रोमीटर. इस रेंज में हम बात कर रहे हैं. फॉर ए डिफरेंट रेंज द बॉडी कैन बी ऑफ डिफरेंट टाइप, राइट. ऐसे नहीं बोल सकते कि मिल्क इस बॉडी में आएगा. हम ये बोल सकते हैं कि किस पर्टिकुलर वेवलेंथ रेंज में कोई सा बॉडी कैसा बिहेव कर सकता है, कैसा हम अज्यूम कर सकते हैं. दैट डिपेंड्स ऑन द वेवलेंथ रेंज. The shape factor with themselves of the two infinite long black bodies concentric cylinder with the diameter ratio. So D2 by D1 is equal to 3. For the inner, what is the self shape factor? Shape factor with themselves means self shape factor. So F11, inner means F11. Isn't it 0 because it is a convex? It will be 0. It will be 0 for the inner. And what is F22? This can be treated as enclosure. So F22 is 1 minus A1 by A2, isn't it? So 1 minus pi D1L by pi D2L. 1 minus D1 by D2. What is D1 by D2? That is 1 minus 1 by 3. That is 2 by 3. 2 by 3. So for the outer surface, it will be 2 by 3. For the inner surface, it will be 0. 0 and 2 by 3. Clear? Right? The next one. The radiative heat transfer rate per unit area, that is Q dash flux, radiation heat flux between two plane parallel gray surfaces. They are plane parallel gray surface. It means A1 is equal to A2 is constant A. Emissivity of both are 0.9. Epsilon 1 is equal to epsilon 2 is 0.9. That is epsilon. Maintained at 400 Kelvin and 300 Kelvin, T1 and T2 is. So can we say Q is equal to sigma T1 to the power 4 minus T2 to the power 4 upon 1 minus epsilon 1 upon epsilon 1 A1 plus 1 upon A1 F1 to 2 plus 1 minus epsilon 2 upon epsilon 2 A2. Because A1 is equal to A2 and F1 to 1 is equal to 0 because they are plane surface. So F1 to 2 is equal to 1. So from here we can say Q dash, which is Q by A, is equal to epsilon 1 is equal to epsilon 2. So sigma into T1 to the power 4 minus T2 to the power 4 upon 2 by epsilon minus 1 will be the answer. This is the formula we are supposed to apply. Can you apply the formula and get me the answer? Sigma is 5.67 into 10 to the power minus 8. T1 is 400, T2 is 300, epsilon is 0.9. (400 to the power 4 minus 300 to the power 4 upon 2 upon 0.9 minus 1 watt per meter square. What will be the answer? What will be the answer in watt per meter square? Can you solve it? Everyone, please give it a try and let me know the answer. Yes, quickly do let me know the answer. I will share the PDF of this session to my Telegram channel. If you have not joined me on the Telegram yet, please do join me on the Telegram by scanning the QR code, or you can use the link, or you can search by the name Mechanical by Chandrasekhar. And do like and share this session so it reaches to other students as well who are unable to join the session live. What will be the answer? Waiting for your answer, guys. Have you understood the concept? This is delta EB upon R equivalent. There are three resistances. One is, this is the surface resistance. This is space resistance. And this is again the surface resistance. So because they are connected in series, so equivalent resistance. Are you getting 812 something? Are you getting 812? B will be the answer, 812. Yes, Shiva, well done, good. What about others? The next one. This is wonderful question. Try to solve this one. The next one. Consider two large parallel plates. Again, A1 is equal to A2 is equal to A. F1 to 2 is equal to F2 to 1 is equal to 1. Because F11 is equal to F22 is equal to 0. Right? Temperature T1 is 727 degrees Celsius. Temperature T2 is 227. Epsilon 1 is 0.1, epsilon 2 is 0.4. They are not same now. Epsilon 1 and epsilon 2 are different. An aluminum radiation shield with an emissivity epsilon 3. It should be epsilon 3. 0.05 on both sides is placed between the plates. Calculate the percentage reduction in the heat transfer rate between the two plates as a result of the shield. Use sigma is equal to 5.67 into 10 to the power minus 8. Can we say Q is delta EB upon thermal resistance? Radiation thermal resistance. Q is equal to delta EB upon R thermal. So we can say Q is inversely proportional to radiation thermal resistance. So what we need to find out is, सॉल्व कर सकते हैं क्या? Q without shield minus Q with shield upon Q without shield into 100 we need to calculate into 100. So it is 1 minus Q with shield upon Q without shield. Or we can say into 100. Or we can say that is equal to 1 minus thermal resistance without shield upon thermal resistance with shield. So that is equal to 1 minus, what is the thermal resistance without shield? When there is no shield, 1 upon epsilon 1 plus epsilon 2 minus 1, that will be the thermal resistance. Then this will be 1 upon epsilon 1 plus 2 upon epsilon 3 plus 1 upon epsilon 2 minus 2. isn't it? So put the values, you will get the answer. That will be the percentage reduction. 1 minus 1 upon, what is epsilon 1? 0.8, epsilon 2 is 0.4, 0.05. 0.8 plus 1 upon 0.4 minus 1 is the numerator. 1 upon 0.8 plus 2 upon 0.05 plus 1 upon 0.4 minus 2. Can you solve this into 100? Yes. What will be the answer? Can you solve it and let me know the answer? इसको सॉल्व करिए और बताइए हाउ मच इज द परसेंटेज रिडक्शन. हाउ मच विल बी द परसेंटेज रिडक्शन? वन अपॉन 0.8 that is 1.25 प्लस 1 अपॉन 0.4 कितना होगा? 0.75. 2.5 sorry. 2.5 plus 1.25. 2.5 plus 1.25. 3.75 minus 1. 2.75. This is 2.75. This will be 2.75. So 1 minus 2.75. Denominator में क्या होगा? 2.75 plus what is 1 divided by 0.05? 20 minus 1. So it will be 1 minus 2.75 divided by 22.75 minus 1 कितना होगा? 21.75. कुछ गड़बड़ हो गया. Is there any mistake I have committed? बताइए what will be the answer? मनिकेत आप ये वाला ही क्यों कर रहे हैं? अभी इसका 812 का जवाब क्यों दे रहे हैं? अभी ये 2.75 हो गया. तो 2 डिवाइड बाई 0.05 40 होगा. सॉरी, ये 40 होगा. This will be 40 actually. 40. So 41.75. That will give you the answer. 2.75 divided by 41.75. 1 minus this answer into 100. So it is 93.413. Are you getting 93.413% reduction? It is 93.413% is reduction. Isn't it? Is this clear or not? Yes or no? So we will be having the national level scholarship test on this Sunday as well from 9 a.m. to 9 p.m. Do not forget to be part of this scholarship test. And based on your performance in the scholarship test, you can get our paid courses for the discounted prices. All right. The next one. The next question. In a certain heat exchanger, both the fluids have, this is from the heat exchanger now. Now some questions from the heat exchanger. In a certain heat exchanger, both the fluids have identical mass flow rate and specific heat product. CH is equal to CC. The hot fluid enters at 76 degrees Celsius, that is TH1, 76, and leaves at 49 degrees Celsius. And the cold fluid TC1 enters at 28 degrees Celsius and leaving at 55 degrees Celsius. The effectiveness of the heat exchanger. What is effectiveness? That is Q actual upon Q maximum. Q maximum is equal to QH is equal to CH into delta TH. And Q maximum is C minimum into TH1 minus TC1. Can we call it as C minimum because CH is equal to CC? CH and C minimum getting cancelled out. Effectiveness is delta TH is 76 minus 49, TH1 minus TH2, and denominator will be 76 minus 28. What will be the effectiveness? What will be the effectiveness? Isn't it 0.56? B is the correct answer. Yes, B will be the answer. Q actual upon Q maximum. That is the effectiveness of the heat exchanger, 0.56 something. The next one. A double pipe. This was asked in gate 90 for 5 marks. Let us solve. A double pipe counterflow heat exchanger is to be designed to cool 12,000 kg per hour of an oil. Hot fluid is oil. It is getting cooled. And CH is, mass flow rate of the hot fluid, m dot h, is equal to 12,000. It is kg per hour. Convert it into second. Kg per second. Convert R into second. Specific heat CH is equal to 1.95. It is in kilojoule per kg Kelvin. From 85 to 55, TH1 is equal to 85 degrees Celsius and TH2 is equal to 55 degrees Celsius. By water entering, the cold fluid is water. The cold fluid is water which is entering the heat exchanger at 30 degrees Celsius. TC1 is 30 and TC2 is equal to 45. If the overall heat transfer coefficient is 400 watt per meter square Kelvin, calculate the LMTD. LMTD is very simple. It is a counterflow heat exchanger. This is, all the terminal temperatures are given, 85, 55, 30, 45. Can you find out LMTD? So delta Tm is equal to 85 minus 45 minus 55 minus 30 upon natural log of 85 minus 45 upon 55 minus 30. That will give you the LMTD. What is the value of LMTD? Are you getting 31.9 degrees Celsius? That is the mean temperature difference between hot fluid and cold fluid. LMTD is 31.9. 31.9 is LMTD. नहीं, 19.74 गलत है. 31.9 will be the value of LMTD. And what is the surface area? So we can say Q is equal to CH into delta TH is equal to U into A into delta TM. 31.9 आ रहा है ना? Equate these two. So mass flow rate of hot fluid is 12,000 by 3600. Specific heat is 1.95, 1950 into delta TH. Delta TH is 85 minus 55 is equal to U, that is 400 into area into 31.9. Can you find out the value of A? The area will be equal to, are you getting 15.28 meter square or not? Are you getting 15? area ना, गलत है. शिवा चेक करिए कहाँ मिस्टेक हो रही है. Is there any mistake in units or anything else? Put all the parameter in their SI unit. Please check and do let me know. Are you getting 15.28 or not? 15.27, 15.28 will be the correct answer. I hope it is clear. The next one. Again, it is a counterflow heat exchanger. Is to heat air entering it. Air is getting heated. Hot fluid is exhaust gases. Entering at 800 degrees Celsius. TH1 is equal to 800 degrees Celsius with a flow rate mass flow rate of the hot fluid is 4 kg per second and cold fluid is air which is entering at Tc1 is equal to 400 degrees Celsius. Mass flow rate of cold fluid is 6 kg per second. These are the parameters given. The overall heat transfer coefficient is 100. U is equal to 100 watt per meter square Kelvin, and the outlet temperature of the air is means Tc2 is given as 551.5 degrees Celsius. Specific heat at constant pressure. Specific heat at constant pressure for both air and the exhaust gases can be taken as Ch is equal to Cp for the hot fluid is equal to Cp for the cold fluid is equal to 1100 joule per kg Kelvin. Specific heat will be taken as same. Calculate the heat transfer area needed and the number of transfer units. So what we can do? We can first find out TH2. Can you find out TH2? So Q is equal to m dot HCH into TH1 minus TH2 is equal to m dot CCC into Tc2 minus Tc1. This specific heat will get cancelled out. Mass flow rate of hot fluid is 4. 800 minus TH2 is equal to 6 into Tc2 551.5 minus 400. So find out TH2 first. What is the value of TH2? How much is TH2? Are you getting? This you should get as 572.75 degrees Celsius. Are you getting TH2 as 572.75? $572.75. Now delta Tm you can easily find out. TH1 is 800. This is 572.75. It is a counterflow heat exchanger. 572.75. Then Tc1, this is the hot fluid, this is the cold fluid. Tc1 is equal to 400, Tc2 is 551.5. So delta Tm is equal to 800 minus 551.5 minus 572.75 minus 400 divided by natural log of 800 minus 551.5 divided by 572.75 minus 400. If you find out LMTD, you must get LMTD to be 208.33 degrees Celsius. This is LMTD. Once you get the value of LMTD, 48 aa raha kya? Yes, the area will be 48. Once you get LMTD, then you can say Q is equal to CH into delta TH, CC into delta TC is equal to U into A into delta TM. From here you can find out area will come out to be 48 meters square, and NTU is equal to UA by C minimum. What is C minimum? C minimum will be equal to CCH, isn't it? So U A by C minimum. U is 100, area is 48, C minimum mass flow rate is 4 into specific heat is 1100. This is NTU. NTU will come out to be 1.09. Please check and do let me know. Yes. So these are some assignment question. Try to solve these questions. This is your assignment number 1. Try to solve these questions at home. This is your assignment number 2. These were asked for 5 marks in previous GATE papers. This is your assignment number 3. So these 3 questions you try, and if you have any doubt, you can always connect with me through the Telegram channel or my email ID. This is all from my side. There are crash course as well as the long-term batches, which long-term batches have recently started. 12 होगा क्या शिवा? NTU 12 होगा? Is it 12? 4800 by 4400 कैसे? 4800 divided by 4400 1.09. 1 NTU will be 1.09. It will be 1.09, right? So there are some courses which are running, paid courses for GATE 2024 as well as 2025 and 2026. If you are interested, you can join our paid courses as well. And if you have not downloaded the BYJU'S exam prep app yet, because the quiz is also there for the same HMT questions, there is a quiz available on our BYJU'S exam prep app also. So do download the BYJU'S exam prep using the bit.ly link. This is the bit.ly link which is there in the description box. The bit.ly link is there in the description box. Please go through the bit.ly link and do download this BYJU'S app and practice some more numericals on your own, right? So that completes my session. See you in the next class. Till then, enjoy, take care, have a good day, good night. Shubh Ratri, Sabba Khair and Jai Hind. Thank you very much for joining in, guys. Take care.